Okay. All right. Now let's go to Myopenmath and look at some of the problems that we're going to be seeing there. See how much time I got left. All right. So let's go and look at some of the problems in Myopenmath. So we're here at the 811 day 5 practice, and let's take a look at this first problem. Get my pen here, and well, we got a polynomial going on here. So we've got x plus 2, x minus 1, 2x plus 1, and x minus 5. So it is in factored form. Those are our linear factors. And notice they say they want the zeros. So just the numbers, just the values of x that make zeros in each of these things. So if we look at x plus 2, if I take x plus 2 and set it equal to 0, right, and solve this thing, what we find is that x equals negative 2. This is the value of x that'll make a 0 inside of that parenthesis. So I want a negative 2 as one of my answers when I type that in, right? This one, x minus 1, well, the value of x that makes a 0 there is going to be a positive 1, okay? For this one's a little bit more complicated. I'm going to work this one out. So I've got 2x plus 1 equals 0, and I'll go ahead and draw my line and solve here. So these cancel, and we get 2x equals negative 1. And then to finish that off, we'll divide by 2. All right, so we've got x equals negative 1/2. That's going to be another one of my zeros here. And then the last one on the end is going to be a 5, right? 5 minus 5 equals 0. And for Myopenmath, we do not need to write that 4 times because of that exponent. So just 1 5 will do here. All right, next one here, we've got the degree. And I'm going to go ahead and clear this ink off real quick. And we'll talk about the degree real quick. So remember, the degree in factored form is equal to the number of linear factors that you have in your polynomial. So this is a linear factor because it has an x in it. So there's 1, 2, 3 linear factors there. And then there's another linear factor here, but since there's a 4 on it, there's actually 4 of these x minus 5. So we've actually got 1, 2, 3, and then 4 more here. So that's going to be a degree of 7. Right, so I would type in a 7 for the degree of this polynomial. All right, and then this is kind of the big one here, this end behavior. So this is kind of different than what we did in the notes where we just described the end behavior using those little arrows to indicate what happened on the end of the polynomial. If you need to, you can go to Desmos or your graphing calculator and graph this and just physically look at what the ends of the function are doing. So as you go off to the left, you're looking for whether or not it goes up or down. And as you go to the right, you're doing the same thing. Is that function going up or down? All right. So you can do that with your calculator or Desmos, but really what I want you to do is to challenge yourself and see if you can do this by just looking at the equation. All right. And this looks intimidating, but really this is just a fancy mathematical way of saying as x goes to the left, right? So as we go towards negative infinity is a fancy way of saying as we go to the left, what is our function doing? All right, and it's either going to go up or down. It's going to go up to positive infinity or it's going to be going down towards negative infinity, okay? So that's all this notation means. This one going towards positive infinity, so as x goes to positive infinity, that is again, a fancy mathematical way of saying as I go to the right. So this is as I go to the right, as I go to the left, all right? So let's figure out what our end behavior was. So again, you have to look at your notes from yesterday where we kind of talked about how we determine that end behavior, but we look at the leading coefficient, which is right here, and you don't see it, but there's a 1 there, and it's a negative 1, and then our degree is 7. So we have a negative leading coefficient with an odd degree, so negative odd, all right? So in a negative odd situation, as I go to the left, we're going to be going up, right? So that's positive infinity. As I go to the right, this function is going to be going down towards negative infinity. Okay, so I just select those and click submit, and it'll tell me like, hey, you got those right. Okay, so that's how you do that. Let's look at question 2 and see what we're dealing with on this one. So you'll notice this one has 3 linear factors and it wants the roots, right? Roots are the same thing as zeros. So we got to go into each of these. And so if it's just an x by itself, well, the value of x that's going to make x be 0 is actually 0. Okay? The value of x that's going to make a 0 here is a 2. And I'm just separating those with commas. In this one, the value of x that's going to make a 0 here is -4. So I'm going to type in that -4. And, you can do it a part at a time and just click submit and make sure that you got that first part right. So it'll give you the green check mark, and then you can come back and try these ones after you know you got that first part right. Okay, so remember what I said in the last problem. X goes to infinity. That's fancy for as I go to the right. This is fancy for as I go to the left. Where are we going, up or down? Okay, so again, to figure that out, I need to know the degree and the leading coefficient of my polynomial. So this has 3 linear factors, so it's a third degree polynomial. So it's odd, and it's got a positive leading coefficient because it's got a positive 1 out front. So this is a positive odd. And looking at my notes from yesterday, I know that positive odds, right? So as I go to the left, that's this one down here, this one is going to be going down. And as I go to the right, it's going to be going up. Okay, so just make sure you select that. This is positive infinity is up, negative infinity is down. Okay, so make sure you get those right. I'm going to submit that and just make sure I got it right. And then we'll talk about the graphs. So I got those right. Okay, so now we have to figure out which of these graphs could be the potential graph of this one. And you can easily just go to Desmos and graph it and compare the graphs if that's what you wanted to do. But again, challenge yourself, see if you can figure out which is the correct graph just by looking at the equation. All right, so let's see, we've got zeros of 0, 2, and -4. So when I look at this, I need the x-intercepts to happen as 0, 2, and -4. Like if I went to this second graph, notice how I only see 2 x-intercepts here. So this could not be a correct graph. Same thing with 2 x-intercepts, so this could not be a correct graph. If I came down here, I have 3 x-intercepts, and it's at -4, 0, and 2, which is what we need. But this first one also has x-intercepts at -4, 0, and 2. So the difference between this first graph and this last graph is the end behaviors, right? So if I'm looking at the ends of this graph, right, this one is going down and up, right? So as I go left, it's going down. As I go right, it's going up. This one, as I go left, it's going up, and as I go right, it's going down. All right, so the end behaviors are flipped between those two graphs. So we need something that goes down as we go to the left, and that's going to be this one. All right, so this one goes down and to the left, right? So this is the one that matches our end behavior. So I'm going to select that one and click submit. We're good. All right, last problem here. And really all I need to talk about on this one specifically is just this y-intercept business. And I'm going to ink up on this one. Okay. So talking about this polynomial here, so notice that this x plus 9 has got an exponent of 2. So I can actually take that x plus 9 and write it like this. So x plus 9 times x plus 9 times x plus 7. Okay. And the quick way to figure out a y-intercept, and we talked about this in the first section of notes, is to take these numbers that are inside of the factors and just multiply them. Okay, so I could do 9 times 9 times 7, and that'll tell me where the y-intercept is going to be. So I'm just going to pull up my calculator and do that calculation real quick. Okay, so 9 times 9 times 7, which means my y-intercept is going to be at 567. Okay. Let's try it. So we got parentheses 0, comma 567, and I'll submit that and make sure I got my y-intercept correct. And sure enough, I did, right? And all I did there was I multiplied the numbers that were inside of the factors. Make sure you expand anything with an exponent first. All right, the x-intercepts are easy to find. We just have to find the x-intercepts. We just have to figure out what value of x makes a 0 here and then write those as points, right? So -9, comma 0 for this one. And then separate with a comma. And the next one, right? I have an x plus 7, so negative 7 will be my other 0, and I'll write that as a point to make it an x-intercept. Right, and I'm going to click submit and make sure I got that right. There we go. And then this is end behavior. All right, so this is saying as I go to the right, as I go to the left, right, left. Okay, so to figure that out, I have to look at leading coefficient and the degree. All right, so the leading coefficient is positive. There's a positive 1 here, even though we don't see it. And it's got a degree of 3 because I have 1, 2. This has got an exponent of 2, 3, right? 1, 2, 3 linear factors, so it's a third degree polynomial. So it is odd and positive. Now, as I go to the left on an odd and positive, it's going to go down, right? So I'm going to put a negative infinity. Okay? So that's just a negative OO. And you should see over here in the preview a negative infinity symbol. And then over here, we're going to say as x goes to the right, again, just looking at my chart from yesterday, as x goes to the right, the function is going to be going up, right? So I need a positive infinity here. Okay. I'm going to click submit. I got those right, and we're good. All right. All right. So hopefully that should help you out with those problems. If you have any specific questions, make sure you send me a message so I can help you out with those. Have a great day, guys.